the questions are captured for perpetuity. I've already got your homework up, so let me share that, what I'm looking at. There we go. Oh, before that, I have to give you guys your daily reminder here. The other class is beating you, okay? This is the icon number of you who have completed evaluations this semester. Can you see that? 14 out of 17 in the other class and only 11 out of 18 in your class. So I thought there was 17 of you, so I messed up, but I made you a deal. If I get at least 15 of you to complete an evaluation, everybody gets a point of extra credit. That was my deal. Because I added questions to the standard forms. And moving forward in this brave new world where I may never be in a classroom again, it's especially important to get feedback on what worked and what didn't work for future planning. So I really would value your opinions if you would take the time to fill these out, and I want to incentivize that as well. So I can't tell who has and hasn't completed them, but I can send out a reminder to those who have not. And so if you can bug each other and make sure that we have as high a completion rate as possible, that would make my life easier. So, okay, let me go back to, no, get out of the way, screen share thingy. I want that tab. All right, let me move it over. There we go. So we had a question earlier from Terry about the drop-down questions, and so that will require going back over some material. Kelly, did you have a question about the computational part? I can. Yes. Okay. Okay. Well, so if you have the first three questions right, then you probably have the right model content. The question four is the test statistic for the likelihood ratio test comparing your HO model to the saturated H1 model. That should be given to you in the output. That mhm. That's where it should be. The test statistic is given as a chi-square. Is it given to two decimal places or three in this homework? It's three. Okay, that is the problem. That would be one strategy is to guess what the third decimal place should be. You should be able to calculate it yourself if it gives you the log likelihood for the saturated model somewhere. Okay, so if it gives that to you with a greater precision, then you should be able to do minus two times the difference and get the correct answer. Yeah, yeah, it's because I ran into problems in the last homework with two digits not being sufficient to get like people were getting the right answer with not exactly the right code, and so I thought I did use three this time. Of course, now I have the opposite problem where not everything's reported as three. So let me know if that doesn't fix it, and I'll look at yours and see if there's some other issue. Okay. No, number six is the root mean square error approximation. That is your RMSEA fit statistic, and that should be given to you. You should get, there's probably an estimate and a confidence interval. This should just be the estimate. And that is a measure of offness per degree of freedom remaining. So that's when we want to be small if the model fits. Okay. Other questions on computational part? Okay, then Terry asked about missing data and likelihoods and stuff like that. And that was the part that we talked about that I did not get recorded because I was a moron that day who did not turn it on, as sometimes happens. So let me find where that is here. So I'm on slide 8 of lecture 6. All right, does everybody have that in front of you? Is supposed to mean predictor and the word endogenous things. So if we go back to just regular regression models like we've done all semester, whether it has a link function in it or not, um, the predictors in those models never had any distributional assumptions. That's because they weren't part of the likelihood. So the model likelihood function that is being used to figure out what parameter estimates are the best ones that make the data the tallest, those concern the distribution of y. So all you have to know is what the predicted y is for each case, and given the probability distribution that you're using, you can figure out what the height is of each case. The problem with that is that the predictors then can't be missing because if you don't have a case that's missing a predictor, you can't come up with a predicted outcome and then you can't get the height for that. So up to this point, there was a very clear distinction. If you have a predictor in a model, it is not allowed to have any missing data, which is a bummer. Let's see. Okay, sorry, I'm just catching up on the chats from like 5 minutes ago. Um, your predictors are not allowed to have missing data, but at the same time, they also don't have any distributional assumptions. The distributional assumptions are all about the outcomes and the likelihood. So if you have a univariate model, for instance, if you have a binary outcome, it's the Bernoulli distribution, and that's the likelihood function. If you have a count variable, maybe it's Poisson or negative binomial, and that's the likelihood. And so the idea of which parameters are relatively best, the ones that should be your estimate, the ones that make the data tallest, depend on having an accurate formula for height. But the predictors had nothing to do with that. Their sole purpose was to create a predicted outcome. So in these path models, where it gets confusing is the role of predictor and outcome is sometimes ambiguous. So in this picture, what I have here on slide 8, it looks like you would say x1 and x2 are predictors, they're exogenous, and y1 and y2 are outcomes, they're endogenous. And indeed, this is the kind of model that you can fit by tricking univariate software like Mixed or Glimix. This model on the bottom, y1 is both an outcome with respect to x1 and a predictor with respect to y2. So y1 is in the likelihood no matter what because it's an outcome of this x1. What happens to x1 and x2 is software specific. And so I have a lot of words on here. Let me just talk you through this without reference to those because that's more detail, I think. Once upon a time, the way that these algorithms worked in terms of the likelihood was using a summary of all of the individual data. So you would get the means for all your variables, the variances for all your variables, and the covariances, and the model likelihood would operate on that. That's what's known as limited information. Anything that uses limited information means that you cannot have missing data because the matrix doesn't understand where it came from. So you have to be able to have everybody contribute to every spot in the matrix for it to be included. The hard part comes in what happens under full information maximum likelihood. That's where the model likelihood is an individual level and you can have missing data. What you can have in particular are missing outcomes. So any variable that is predicted by something else is automatically an outcome. It has distributional assumptions and you can have missing at random on it. So that's the same as what we've had all semester. What happens to predictors is program specific. So if you are using Stata, SEM, for instance, then it puts your predictors into the likelihood even if they're not really outcomes. So it's sort of an old school treatment of making all of the variables in the model part of the likelihood at the same time, which means that they can have missing data assumed missing at random and still be included, but at the cost of having distributional assumptions. Because these models operate on multivariate normal, they would say that your predictors are part of that. To be honest, I'm not sure how big of a problem that is. I've gone back and forth, and I think this is actually a question for simulation. I'd have to do more research to see what's been found. But you don't get a choice. So it's the predictors, even if they are predictors, so long as you're using full information, maximum likelihood, and data, they are outcomes. That means they have distributional assumptions, but they can have missing data missing at random. In M+, you get a choice. By the way, the same is true in Lavon and R, you don't get a choice. Everything is in the likelihood, which means everything is multivariate normal, unless designated otherwise. In M+, you have the option to treat your predictors as they would be in any other regression model, where they're not in the likelihood. All they do is create predicted outcomes, and because they're not in the likelihood, you cannot have missing data, but then you do not have distributional assumptions. Okay, I'm going to pause for error. Terry, did that help at all? Yes and no. Okay, let's go back to the question. So anything that is not in the likelihood does not have a distributional assumption. I can just tell you that. How's that? Narrow it down to two choices instead of four. So I had to do some digging. We were talking about this before everyone got here to try and figure out what the hell the programs are doing, because this is a common point of misconception. Because certain textbooks are written from the perspective of what the programs they use can or can't do. And so you'll find textbooks that say that in path models, all variables must be multivariate normal. Well, that's not entirely true. That's how it operates if you request full information maximum likelihood in Stata. That's what happens in Navon. That's what happens in Proc Calis. But that's not what happens in M+. So you just kind of have to know what your program is doing under the hood, so to speak, and that may change across versions, making it even trickier. So, all right. Other questions on homework so far? By the way, I updated grades this morning, so your current point totals as of everything you've completed today are in there, so you can see where you stand. This last homework isn't due till the end of finals, so we got another week or so to work on that. Any other questions? The one part that we haven't talked about yet, at least seen the example, is how to make indirect effects. So that's what I want to make sure we have time to do today. So I have example 6A up here. I don't know if we're going to get through 6B, but I definitely want to get through this one since this is analogous to what you're doing on homework. Would you like to hear the background story of this example? It's a true story. It involves reviewers. Thank you, Molly. Yes. So this is a paper. This is a colleague and friend of mine at the University of Nebraska, Sarah Gervais, and she had submitted this paper that is based on this path model right here. And Sarah knew what she knew in graduate school, and so the way that she attacked this problem is to do like 7,000 regressions to try and figure out all of these paths, right? So a regression predicting this variable from mindfulness, this variable from mindfulness, this variable from mindfulness, and then having some of them with gender and gender interactions, and there was 7,000 regressions. And the reviewers were like, oh my God, I can't handle this. Can you please put them into one model? So she came to see me, and I said, sure, we can. And so I am now second author on the paper, which was successfully published. So this is a mediation model where we have one X variable, which is mindfulness, and there are four supposed mediators in how mindfulness predicts warmth towards feminists. These are various types of sexism. So motivation to respond with it internally, externally, overtly, or benevolent, which is being sexist, but in a nice way, like holding open doors. These variables to me, of course, not being in this field, all sound like synonyms, and so I went ahead and labeled them with X, M1, M2, M3, and M4, just so we could sort of keep them straight. So this has 4 potential mediators, 1 X, and 1 outcome. And as part of the analysis, she wanted to see whether or not these relationships differed by gender. So I'll show you one model that's collapsed across gender, and then a second model that allows differences in all of these parameters across men and women, what's known as a multiple group model. Okay, let's see here. So here's the correlation matrix that we're going to be path modeling, so to speak. You'll note that not all the paths are significant, but some of them are. I had originally built this example for a class at the University of Kansas like 5 years ago, and I was doing proc Calis with them, so I left that in here just so that you could see that. But Calis has the same limitation that Stata Sem does. It assumes all the variables are in the likelihood, so they all have distributional assumptions. So that's in there just as sort of a historical if you want to know. But here's M plus. We'll start with that, and then we'll do Stata. So for your homework, I gave you a starter part that looks like this, that helps you read in the data, name everything. So data, as we talked about last time in M+, has to be some kind of text file. So comma separated values is convenient because that's something you can open up in Excel and look at. If you try to open up .dat files, you have to go through extra import steps for that. So long as the data file is in the same place as the input syntax, then you don't need to write the path. We have the names of all the variables in the data set, as well as another command which identifies which specific variables are in the model. So if there's not a one-to-one correspondence, if not every variable that's in your data set is going to be used, you have to make sure to use this use variables option. Otherwise, bad things will happen. So I have all of these original variables that were in the data set with two, actually, these ones are here. And there's 2 at the end that I've created within M+. So M+ does allow you to make new variables the same as in any other program. Mindfulness was measured on a scale of 1 to 4 as the mean across items. And so I centered it at a 2 so that the intercepts for all of the outcomes would be interpretable. So that is still the same with respect to what we did, always centering predictors that are purely predictors. And the other thing is that we ended up going through several iterations of what our outcome would be with the revisions to the manuscript. And it worked out that I needed to compute a new variable to measure warmth towards non-traditional women specifically. So I did that inside M+, because by then we were already well into the path models. So these are new variables that are being created, and they get added to the end of this list right here for the use variables. So centering and then just making a new one right here. I've got more options for the output than what are going to be shown in this handout. So I'm asking for the standardized solution here, and when I went to get the version to test the indirect effects, I bootstrapped those. So those are the options to turn on these things, confidence intervals as well as confidence intervals for the bootstrap. So just wanted to have those there for your future reference if you wanted to have M+ do that. Okay. So in terms of the syntax, mindfulness, the first variable in the mediation chain here, let me go back to the picture. In M+, I have a choice to make as to whether or not I want mindfulness to be a outcome with inside the likelihood. In this case, because we had a few people who were missing data on mindfulness, we decided to do that. So this is done for you automatically inside Stata. You don't get a choice inside the SEM. But in M+, the way that you bring a predictor into the likelihood so that it's an outcome is to estimate its mean or its variance or its covariances with other variables. So the first part of the syntax in M+ is doing that. So M plus syntax, any of the variable names that are in brackets is going to refer to either its mean or its intercept. It's a mean if it's a predictor, it's an intercept if it's an outcome. And just listing the variable by itself refers to its variance if it's a predictor or its residual variance if it's an outcome. So I have labeled each of these parameters. So this is the intercept for x, this is the variance for x. These, likewise, are the intercepts and residual variances for all the other outcomes to be predicted. You do not have to type this. I'm including it here for completeness, but these are automatically estimated for you. What you do have to type, though, are the paths. So in the lines that are green with the exclamation points, those are the comments. So trying to wade my way through the picture here. So we have first the X to Y path. So non-traditional attitudes as the Y outcome on mindfulness. So that's the C path of the mediation triangle, so to speak. Then we have the left side of the model. So this is mindfulness to each of the mediators. So the middle set of variables, the M's, that's what's highlighted here, is being predicted by mindfulness. And I have labeled each of those paths, X to M1, 2, 3, and 4. The right side of the model then is the middle mediators predicting the Y outcome. So Y, the first word there, on the mediator variables. And then these are the labels that I've attributed to those paths so that I can make them do math to create indirect effects. I want all of the mediator variables to have covariances. And so this with command in general is how you add covariances. If you have a list of variables on each side, it estimates all possible covariances between them. So it's a shorthand way. And I figured out how to do that in Stata, by the way, so I'll show that to you in just a second. And then last but not least, model constraint with new. That is the analog to estimate statements in SAS or LINCOM statements or NLINCOM, NLINCOM in Stata. You can do math on model parameters as linear combinations or nonlinear combinations in this case. So to be able to get the indirect effect, let me scroll back up here just a second. So the idea of whether or not the relationship between mindfulness and warmth towards feminists is in part due to motivation to respond without sexism, for instance. It's this path from mindfulness up to the mediator multiplied by the path from the mediator to the outcome. That's what's known as an indirect effect. And the reason we ask for that is because that is the formal test of the extent to which this path from mindfulness to the outcome Y would have been different if not controlling for the mediators. So I'm evaluating 4 different mediators and the extent to which each is responsible for some kind of difference in the path here. So the original path is the C, and the path after controlling for mediators is the C prime. So I'm going to make manually 4 different indirect effects by multiplying the A path from mindfulness times the B path of the mediator to the outcome. So X to M1 to Y, to M2 to Y, M3 to Y, M4 to Y. So each of these then is a multiplicative combination. So this would have to be, it'll be N LINCOM in Stata. Estimate and SAS will not do this for you, but in ProcCalus, there's a way to ask it a different function that's known as test function, allows you to do this kind of nonlinear combination. If you are in models that have all multivariate normal, which I am, shorthand for that is a command that's built in called model indirect. That gets you all of the indirect effects from non-traditional or mindfulness into non-traditional attitudes. And it also gives you the total of them. So it gives you another piece of information that is separate from that. That's only available in certain situations, which is why I wanted to give you the more direct way of doing it for yourself. Okay, So questions from M+ users on any of that? Good? Okay. Then the outcome. Here's the output. Okay, here's a question for the audience. I'm going to highlight this right here, and I'm going to highlight that right there. What does that tell me? Try and make it a little bigger so you can see. The HO log likelihood is exactly the same as the H1 log likelihood. My chi-square test is 0, my RMSEA is 0, and my CFI is 1. What does that tell me? HO is not worse. You have a saturated model. Any other guesses? Because of this right here, I have no degrees of freedom. That means my model is just identified, meaning my model is the same as the saturated model. So I can't say that it's not worse because I have no degrees of freedom to test it with. It's not over-identified. Every possible path in terms of a direct relationship is in there, either as a regression or as a covariance among the mediators. I've got them all in. And wouldn't you know it, reviewer 3 insisted that we provide fit statistics for our model. Any thoughts? Dear reviewer 3, our model is just identified, which means it fits perfectly. Thanks for playing. Here's a source of confusion potentially. This chi-square test. Stata gives this one to you too. That's significant. What is it telling you? Do you remember? The chi-square test for the null model or for the null baseline, as it's called here. Any guesses? This one is a comparison of the saturated to the null model. The null model says there's no covariance at all. So this is your test of whether you have anything worth modeling. It has nothing to do with your own model that you made. Yeah, the null model is the independence model. Each variable gets its own mean and variance, but there's no covariances amongst the variables in the likelihood. So yeah, ignore this. This is not helpful information. The one that you care about is the chi-square test of model fit, which in this case is perfect because our model is the saturated model. So that means I don't have to worry about misfit. I can go straight to the results. So I've got all of the relationships of the mediators. Here, actually, this is X, and here are the mediators on Y, and then every combination of all the others. I've got all possible covariances among the mediators themselves. Intercepts for the variables that are part of the likelihood that are outcomes. The variance of mindfulness, which is all of its variance in this case because it's a predictor, homework question. The mean for mindfulness, since we introduced it into the likelihood, And here are my new indirect effects. So those are the tests of whether or not there's significant mediation of any of the middle variables. If the results of X to Y are different after including them, and it looks like I have a significant mediation for 2 out of the 3, although these are the p-values you're not allowed to stare at, or reviewer 3 is going to yell at you. These are the ones we're supposed to do bootstrapping to make sure are okay. So that's where the extra syntax comes in. All right, Stata folks. Your code looks similar to the other example that we did. The intercepts are referred to right here as the prediction of the constant onto each outcome. You don't have to type that if you don't want to. This is the part that you do have to type, the regressions between variables. So the first one is x to y. The second line gives x to each of the mediators, and the third line gives each of the mediators to the outcome. I'm asking it to print the mean and the variance of mindfulness. So in contrast to M+, this is not actually changing anything about the model. In M+, it brings it into the likelihood. In Stata, it was already there. So this is just getting the same output that M+ provides. Each of the outcomes gets a variance. That is estimated by default. You don't have to type that. And here's something new I learned just last week or the week before whenever I put this up. Do you remember what the word unstructured means? Remember that? Everything gets to be what it wants? Yeah, there's a shortcut here. So this cove struct with all of the variables, comma, unstructured, that's the analog to estimating all possible covariances separately. So the with statement in M+, where the same variables are on each side does this, there's a formal option for this as well. So this saves you a little bit of typing. Otherwise, you'd have to type out 6 different covariances between the 4 variables to get them all. This is just a shorthand. MLMV gives it full information maximum likelihood. That's not a default. That's what you have to add. And this thing, SStat T effects, that gives you some of the same information as model indirect, but not all of it. It looks like it combines indirect effects across variables and it wouldn't give me separate ones. I tried to figure it out and I couldn't. So I wouldn't recommend that in practice. Instead, what I would recommend is using NLCOM to get the indirect effects. So again, to figure out where these names came from, because these are not my names, they're not my own labels, they came from this command coeflegend right here. That's how you figure out how Stata is naming things. But in general, each of the regression paths starts with an underscore b, and then the y variable, colon, and then the x variable. So here is the analog to the model indirect in M+ that makes multiplicative combinations to form the indirect effects. Yeah. Hmm. Oh. It's possible. It's particularly for NLCOM. There was an example that I made a couple of years ago that when I got it out for this class no longer worked. It Yeah, so if you go down to this SEM CoF legend thing, let me find it in here. I think I put it in here. Maybe I did. No, I didn't. Of course I didn't this time. The one time I need to refer to it. It is inside the example original syntax files and full output. That's where I got those labels from. So if you run that before you generate the indirect effects, then that should tell you what your version of Stata thinks they are called. And if you can't figure it out, email it to me and I'll try to help you troubleshoot. Yeah, I think I ran this one probably was in 14 because that's what I have at home. But I made sure that your homework worked inside whatever version is in the virtual desktop, so you shouldn't have any issues with that. Okay, so yeah, something like that. The numbers should all be the same. Because this model is simple enough, so to speak, in terms of estimation, or your homework data rather, that there wouldn't be any instability issues that between versions, I would think. So Molly says that Stata inside virtual is 16. So just as an FYI. All right. Other questions on Stata code? 16 is way better, she says. Well, I'm encouraged. We'll have to see. That would be nice. Yeah. So code completion in Stata 16. That is very handy. I agree. So, so here's the results of all of this stuff. Same as SAS. Confidence intervals are given. Here's the means. Here's the variances. The E dot inside these just means it's a residual variance as opposed to a variance, conditional versus unconditional. It spits out part of your fit statistics here that lets you know that yes, this is indeed a saturated model. There's all the indirect effects, and here's the same information with respect to model fit. The chi-square is exactly 0 because we have no degrees of freedom left. Everything is perfect because this is saturated. So this cannot be wrong from the perspective of accurately characterizing the covariances in the data. Whether those are worth characterizing is another question. Then we get our square values from the standardized solution, and so on. Just to give you a sense of what this would look like for a published paper, at least how I did it anyway, I did include the paper itself. So let me pull that up real quick. Because if you put in tables of output that look like that, someone's going to yell at you. And well deserved, I think, too, because that's not helpful. Let me scroll to find. Words, words. There's my PowerPoint picture. There's a ton of programs, by the way, that people use to draw structural equation models and path models. I find that PowerPoint is, while slow, just as functional. Trying to get to the table. It's slowly scrolling. There's some means. Come on, you can do it. There's the correlation matrix that I stole. Here we go. So here's the table in the publication that corresponds to the next model where I broke things down by gender. And you can see that I actually used the labels in here, like X to M1, M2, M3, because it gets hard to keep track of all of this stuff. So I have mindfulness predicting each of the mediators, and then warmth, the outcome predicted by each of the mediators, and then the indirect effects. So I'm giving them unstandardized estimates, standard errors, the p-value that goes with it, and then a standardized slope for each of those. And then since we're going to be comparing the model across men and women, there's the chi-square tests of gender difference that are coming next. So, all right. So questions so far on how to make indirect effects. All right. Do you want to see a multiple group version? Why not? So I didn't ask you to do this in your homework. This is just sort of extra. But to answer the primary question about whether or not the relationships among these variables differ by men and women, there are two different ways that you could tackle this question. Now, the way that you guys know, if you want to know if a predictor has a different effect by gender, what would you do? What do you know how to do right now? What does that sound like? Eagerly watching the chat window. If I want to know if a given predictor's effect is different by gender, what do I do? Interaction, correct. That is still one strategy. But there is another strategy that can be used to answer such interaction questions whenever the interacting variable is categorical, is a grouping variable. And this is what's known as a multiple group model, where you literally split the sample by group and you simultaneously estimate a model for each group. Because it's simultaneous, analogous to how it would work in a multivariate setting, we do multivariate so that we can get contrast between outcomes. If it's simultaneous, we can get contrast between parameters within each group. So the difference in what is possible in a multiple group model is that in addition to having differences in the regression slopes, in this case the direct effects and the indirect effects, you can also have differences in the model's residual variances and covariances. So it is analogous to allowing the G matrix or the R matrix in multivariate models to also differ by gender, in addition to all of the fixed effects. So there's more things you can let vary by gender in a multiple group model. It doesn't extend into moderators, interacting variables that are quantitative. This approach doesn't work for that. And so what people commonly do is cut them up into groups. That's not a good idea. But in this case, she had gender measured as a binary variable. And so we're going to do the analog to interaction terms, but as a multiple group model. So in M+, the way that this works is that here's the model statement. And everything is exactly the same as before, with one exception. In front of all of my labels, I have a tiny lowercase m. So each parameter is now male specific. I have a second command that's model women, where everything is exactly the same, but now I have a lowercase w. So everything is female specific in this case, women specific. So what that allows is every single estimated parameter to differ by group. You can allow some of them to be the same and some of them to be different based on theory or what the data suggests is necessary, but this is sort of the biggest possible model where everything differs by gender. And just as a coding tip, by the way, find and replace can be case sensitive. So it is not a coincidence that I used a lowercase m in front of everything here and a lowercase w, because to write this code, all that I had to do was copy this, paste it down, and say everywhere there was a lowercase m, put a lowercase w instead. So you can create tricks for yourself to not have to write quite so much if you take advantage of the case sensitive aspect. So anywhere it saw like a lowercase m with a capital M after it, for instance, I know for sure that that was one of my labels, not one of the names of the variables. So that's what it looks like in M+. The model is still saturated, but one thing that it does do is give you the contribution of each group, so you can see to what extent misfit is group specific. It gives you the solution for each group. So there's group men up here, and those are all the estimates from the male model. Group women in that case, and there's all the estimates. And it doesn't directly give you any information about the differences. I'll show you how to get that in just a second. This is where actually Stata wins on this. So Stata has a much more succinct way of doing all of this with just this line of code. So it tells you what you want to group your model by, and then what level of what's known as invariance you want, meaning which parameters do you want to constrain to be the same across groups. So G invariant none means estimate everything different. So it's one line of code that does the same thing that M+ does. And then I have gender specific NLComs to get the indirect effects. And note that because gender is considered a grouping variable, it's using the values of gender inside these statements to clarify which equation it's for. 0BN refers to which one is the baseline, and then 1 is the alternative group. Another option that is nice for multiple group models like this in Stata is this G invariant SStat, which tells you gives you a test of the difference across parameters. So it does that directly so that we don't have to do that. That is a very helpful thing. And it also organizes the table so that you can see what it is for each group. So for instance, this is the relationship between X and M1, the first mediator, specifically in men, specifically in women. So everything is differently organized. So there's all of the model parameters, there's all of the indirect effects, the R square per group as well, the test to fit, scrolling, scrolling, scrolling. And then if you had forced these things to be the same, actually, no, let me take that back. It gives you a test of whether or not the parameters are different for every single one built in here, so you don't have to do that. I didn't know how to do that at the time when I did this work. So what I ended up doing is a million versions of the model in which one path was constrained. So for instance, I'm testing whether or not the X to M1 path varies across genders right here by taking off the labels that are gender specific and using the same label for both, which creates a constraint. It's forcing the X to M1 path to be the same. And so then the end result of that is that I have given back one of my degrees of freedom by saving one path, making the two paths to be the same. And so then that is the chi-square test for whether or not that path can be constrained across groups without hurting model fit. So in this case, it cannot. So it looks like the X to M1 path needs to be different across groups. And so that is, let me find, that is that one right here in Stata. So Stata does this way more efficiently. It tells you what it would be in terms of the change in model fit if each of the paths were constrained equal across groups without you actually having to physically re-estimate the model to get that answer. So pretty cool. I have to say I like Stata more as I get into it because it has these sorts of shortcuts for people who are doing a lot of data analysis to try and make it a little more efficient. So I do enjoy that aspect of it. And so then, yeah, this is what it would look like if you wanted to do that manually in Stata. You can use @ signs to turn on individual parameters on or off. And so in this case, they're both constrained to the same value, which is A. And then the test of the model fit is the same test as what that individual parameter was. So, and for a results section, see the original manuscript. So we've got the whole thing there. So, ta-da. All right, what do you think, folks? Path models, yay or nay? Come to the dark side. The dark side is R. That's where the dark side lies. Yeah, so path models are a way to get a lot of things done at the same time. Yeah, it's okay it'll be a little hesitant. It can be overwhelming to try and diagnose misfit when you have 7,000 variables at play. So strategically in fitting these kinds of models, I think it's a reasonable thing to sort of work like with smaller sets of variables and figure out what needs to go together and then like work in sets to bring them together. That's the way I teach SEM as well. Kelly got the model correct on the first try. Good work, Kelly. That is non-trivial. So I gave you it's a simulated data set out of a real publication where they fit two different path models where they could have just fit one. So they took sort of like this piecewise approach a little bit too far. So I wanted to see if you guys could fit the right one, so to speak, that has everything going on. So I think it's well within your purview. Other than the indirect effects, there's no other interaction terms or simple slopes or any of that stuff this time. So, but you can use model constraint or NCOM or LinCOM to get all of those things the same as in regular models. So there, that's a much prettier picture. All right. So questions on homework or anything else at the moment? Any of that you want to hear again? Okay, then we have just enough time, I think, to show you my last example. I'd hate to think that I put it in here and didn't actually get to it. I didn't get to the different score versions of M+, but that's okay. I can live with that. Logistic mediation. Here we go, example 6b. So this is one of my proudest accomplishments. I made an entire paper out of one significant correlation. So there's a trick for those of you who are trying to increase your publication history, as you all should be. Brief reports. Brief reports. A lot of journals have a format called brief report, which is a very short paper for something that doesn't need a lot of room to explain. So for instance, this is based on my dissertation data. Once upon a time, I was interested in measuring visual attention in older adults and how that was a risk factor for getting involved in accidents, automobile accidents. I did a follow-up study to my dissertation where we had research assistants call the subjects and ask, "Hey, in the last 5 years, have you like crashed your car or anything?" And I found a significant relationship between their performance in a low-end driving simulator in my original dissertation and their subsequent rate of having accidents 5 years later. So that lends a little bit of validity to the performance in the simulator as a real useful measure of driving ability. And so I made a brief report out of that one correlation. But it looks just like a real paper on your CV. They just can't tell that it only takes up like 2 pages. So if you have something that is not a huge contribution but deserves to be out there just the same, I would recommend the brief report format. So here is the model that I wanted to show you. So on the left-hand side are variables from my original dissertation study. So we have gender, age, a composite measure of visual impairment, 3 subtests of a measure known as the useful field of view, and the whole point of my dissertation, which was making this new measure of attentional search speed. Those, in turn, all predict simulator impairment in the original study. I then, in the subsequent follow-up study, collected a report of whether or not they had limited their driving in the last 5 years, whether or not they had engaged in an accident, at least partially at fault, and whether or not they got a speeding ticket. So first, can I get a round of applause for this figure? Can I? Because like, look at this. Is this not beautiful? Like this figure probably took 10 days to make, to try and figure out how to get all of the lines on here without it looking crazy. So I took some shortcut liberties to try and make the picture more easier to read. So like the first number on each of these boxes is going into one like common line that are all going over here into simulator impairment. So like this common vertical line here is trying to take the place of all the individual lines that would have to go into this variable. And then likewise, the dashed lines are all going down to this common line that goes over here into this variable. So you can bend the rules of path models a little bit to try and make it so that your the paths themselves are actually still readable. And all of these, by the way, are no, I guess they can't be. They're unstandardized coefficients, I think, and then standard errors in parentheses. So I have this thing floating out here in blue, right? This was not part of the original paper because you know what? I screwed up in the original paper. Can you believe it? This was published in like 2010 or something, and I screwed up. In the original paper, stated that the model was just identified, and so it fit perfectly. But that is not actually true. There is no direct path between accidents and speeding tickets as my multivariate outcomes. The reason for that is because I didn't want one to predict the other, and when I tried to add a covariance, M+ wouldn't let me. Each of these variables is binary. So what is happening when they are predicted by these other boxes is that we are fitting a logistic regression to each of the binary outcomes, whereas the paths between my variables on the left and the middle variables here, which are being treated as normal, those are regular regressions. So this is something that I didn't learn for several years after that. How do you put a covariance between two binary outcomes? If you don't have a residual variance, you don't have a residual covariance, at least in full information maximum likelihood. So in this example, I expanded what I did in the original paper to include this thing right here. That is a random intercept. So random intercepts, we talked a little bit about this. Random effects in general are the exact same thing as latent variables. It's an unobserved source of covariance. And so what this is doing is allowing a relationship between accidents and speeding tickets that goes through this intercept. These two blue paths right here are fixed to 1, and the variance of this thing is being estimated. So that is the same way that in a generalized multivariate model, we would induce covariance between the residuals of outcomes from the same person, even when we don't have an R matrix to do so. You can do so with a random intercept. So something I learned since then. Sorry for being wrong in the original paper, Scientific World. The other thing that I added to this that I didn't do in the paper because I didn't care about it was estimating an indirect effect. So I have an indirect effect that goes from this variable right here, driver scan, the thing that I cared about, to simulator impairment to accidents. So the thing about that indirect effect, though, is that it is almost impossible to actually try to interpret as a number, because the path from driver scan to simulator impairment, those are both being treated as normal. So that's a regular regression path with no link function, whereas the path from simulator impairment down to accidents, that's a logit. So the indirect effect is an identity link path multiplied by a logit path. You can still ask M+ to do it and get a standard error for it, but to be honest, I have no idea what it means. It works out to be marginally significant in this case. So in general, with respect to expanding path models to generalized linear models, if the outcomes at the end of the chain are the ones that are not normal, that's no problem. But it gets to be a lot trickier if the outcomes in the middle, if the mediators are not normal, because then how they're being treated as a predictor is different than how they're being treated as an outcome. So like if this simulator impairment right here were binary, what that would mean is that the path from this side to the mediator would be a logit, but then when it's used as a predictor of something else, it would be treated as a dummy code, not a logit. And that may differ across software in terms of how that's implemented. So that's where the tricky part comes in, is in mediation with non-normal outcomes. If they're mediators, it's tricky to interpret. If they're on this side of the outcomes, if they're outcomes without it becoming a predictor of anything else, then it's cool. All right, so I wanted to show that to you. Ta-da, bringing it wholesale. All right. Questions about any of that or comments? No, everyone's fried. Are we tired? Yeah, it's okay to be tired. I'm tired too. Um, so in terms of moving forward, I noticed a number of you have signed up for SEM in the fall. Yay. Um, between this class, yeah, Zoom overload, no doubt. Just looking forward to the fall. Between this class that you're in right now and experience with linear models from other classes, you will be totally fine to take SEM in the fall. I think you will find you'll have an advantage relative to some of your classmates who haven't had this material. So I would encourage any of you who think that you want to take structural equation modeling, which is doing this stuff with latent variables to better measurement, to take it in the fall, because it's not coming back for at least 2 years. So just as a plug for that course. The other advanced courses that I teach, hopefully Longitudinal may come back in the spring. I'm hoping. So yes. I know that there's a few people who've been waiting for that, and I'm hopeful that I'll be able to fit it into the rotation. So the bad news is that it may still be on Zoom. The good news is that you can come in your pajamas. So, we'll see how it goes. All right. Then I think that's all I wanted to say. Don't hang up yet. Other than I wanted to say thank you for all of your efforts, for hanging in there this semester. I know it's been unusual and difficult and challenging in new ways, but I'm very proud of the fact that we were able to get through this, that everybody seems to be doing well. Please don't make me fail any of you. Please, 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 please turn in your work. If you need my help, please let me know. I have office hours today and I have office hours every single day next week in the afternoon. So if anyone is still struggling with pancakes or crepes, or if M Plus is giving you fits, please let me help you. The other thing I wanted to say is that by sticking through one of my classes, you have earned a lifetime privilege of being able to bug me if you need help with statistics. It would make me really happy, actually, to know that you are taking the stuff that you're trying to learn now and using it to better your research and your lives. That would make me really happy to see. So please don't hesitate to reach out if you need help. My ultimate career goal is to make myself obsolete so that no one needs me anymore because everyone can do this themselves. So the closer we get to everyone being able to be self-sufficient, the happier I'll be. That didn't come out the way I meant it, but I want to empower you. That's where I'm going with this. Self-empowerment. Because if you learn this stuff, someone will pay you. I can guarantee it. And learning this stuff, even if you're not going into statistics as a field, will set you apart from other candidates for a job because quantitative methods is where it's at. So, all right. Anything else before we adjourn? All right. Then thank you. Good work. Don't be strangers. Take care of yourselves, and I hope to see you in the fall. Can we clap it out? Can we clap it out for everybody? Good work, everybody. All right. Take care of yourselves. Signing off for now.